So the thing to remember about these parametric equations is that at its very basic level, to work out what this function looks like, and they've sketched it for us, we take our x equation and the permitted value of t's, which in this case is any value of t, and we work out some x values, and then we do the same for y, and then that gives us xy pairs which we can plot on a graph. So for example, when t is 1, x would be equal to some value of a times t squared times 1 squared plus 1. So that will be a plus 1. And when t is 1, y is equal to 9a. So that value of t gives us 1 point. And so each point on this graph has a value of t that generated it. Okay? So that's true of this point here, for example, 4, 0, which is this question first directs us to look at that point there. It says that this curve with these parametric equations passes through that point 4, 0. So what it means is there's a value of t which makes the x equation equal to 4 and the y equation equal to 0. And it'll be the same value of t in both cases. So we can use that fact to find the value of a, because if I replace x with minus 4 and y with 0, I'm going to get two equations with a and t in them. Two equations, two missing values. I should be able to solve them simultaneously. So go on, have a go. See if you can find the value of a. We're told that this curve passes through this point here. So write me an equation about, sorry, it's minus 4. Write me an equation about x, write me an equation about y, and see if you can decide how that sorts itself out. It will be the same t in both equations because one value of t gives you the coordinates. Sorry, I've written that wrong, haven't I? There's an important phrase in the question which allows us to get somewhere with this. It says A is non-zero. What does that mean, Charlie, I can do to this equation? Divide by A. 0 is your friend, so I can divide by A. I can only do that because A can't be 0, so that's good news, isn't it? Divide by A, I get that. So I know that at the point 4, 0, t is equal to -2. So if I substitute that into the first equation, it's the same value of t, which gives us that point. I'm going to get the value of a. I've done something wrong there. Oh no, I haven't. So a is -1/2, and a is a constant, so it's always going to be -1/2. T is a variable, so each coordinate on that graph will give me a different value of t, but a is a constant, so I'm going to, rewind to the start of the question now and rewrite the two equations. The x equation becomes -1/2 t squared plus t, and the y equation becomes -1/2 times t cubed plus 8. So individual coordinates on a parametric function will have the same value of t for both x and y, so we can use that to solve problems. Here's the second part of that question. We're now asked where that graph crosses the y-axis. There are two places, A and B. Harry, what do I know about those 2 points? What will they both have in common? They're on the y-axis. What's always true about points on the y-axis? So I start off by asking, what value of t will make x equal 0? So I look at that equation and answer that question. What value of x makes t equal 0? So I'm trying to work out what the value of t is. Once I've worked out the value of t, I'm going to use that value of t and work out the values, they're going to be 2, I know that from just looking at the graph, of y. So it might be that we get one answer here which gives us 2 answers here, or there might be 2 answers here which give us 2 answers here. So see if you can go, but start, because we're asked to find coordinates where it crosses the y-axis, we start by asking, in this x equation, what value of t makes x equal to nothing? And that's a quadratic. You can use your calculator, or you can remember 0 is your friend. So there's nothing to stop you using your calculator. C is 0, but I'm hoping you might have stand a fighting chance at factorising that, particularly once you've dealt with the minus and the half. You got solutions, George?
I do not.
Well, if I factorise it, what values do I get from solving that?
2 and 0.
2 and 0. So the values of t that make x equal to 0 are 0 and 2. So they'll be the values that I need to use to work out the y point. So I just substitute those into my equation and get the y values, and that answers the question. So the coordinates are 0, -4 and 0, -8. And you could perhaps picture a very similar question asking where the line crosses the x-axis. We would have done the reverse. We would have asked, right, when is y 0, found the value or values of t, used those same values of t in the x equals equation, and that would have given us the points. Okay, second and last example before you mash it up and get you to try some for yourself. So that was about when finding missing values when you know a pointer goes through or intersections with the axis. This is a simultaneous equation question. We've got our parametric equations and we want to know where it meets a particular other line. In this case, x plus y plus 4 equals 0, which is a straight line. It's a straight line. And I use the similar approach to before. I work out the value of t. So what I do is this. It's quite neat. You've got your x equals and your y equals equation, and we want to know where that, and remember that's one line, one curve. That's one curve described parametrically. We want to know where that crosses this line. So what we do is substitute it in. And that gives us an equation with just t's in it that we can solve. Once we've solved it, we use those values of t to work out the x values using the x equals equation, and we use those values of t, or value, does it say here? We're looking for one point, so the value and we get the y value as well. So we work out the value of t and then we use it in the separate x and y equations to work out the coordinates. Each value of t will give us a coordinate. Okay, so this gives us a value of t of -2. It's a repeated root. You can factorise it or use your calculator. So to work out the coordinate at this point, I just make t equal to -2 in my t equals and my y equals equation, and that gives me 4 and -8. So that's the place where the curve, remember this describes a curve, one single curve, crosses the straight line. Page 211, questions 4 and 5. So for number 4, I've substituted this point into my two separate x and y equations, x and y. I look at the x equals equation this time. Whatever b is, this will be 0 if that equals 0, and really that's what I want to find out. I want to find out what t is. So if that's 0, t is 3/2. So I'm going to substitute that into the second equation. I'm going to multiply that out actually. So that's 9/4, so that's minus I hate fractions. Ooh. Wrong. What have I done wrong then?
Is that 1 minus t squared?
Oh, there's a b there, isn't there? Sorry. Thank you. Thank you. There we go, right. Yeah, so I multiplied that out. So b times 1 and b times t squared, which is 9/4. I multiplied everything by 4. Sorted out b's, divided by -5.